of algebraic examples. So we've just been looking at numerical things so far, but each of these final two involve just a little bit more awkward. This one here, we have to find the value of 2 to the power of p squared mod p. P's prime, and I know that the highest common factor of 2 and p is equal to 1. So even though, well, it's obvious they're both prime, of course it is, we've still got to state this. We've got to say why we can use Fermat's little theorem. There will be a mark given for that in any exam question. So Fermat's little theorem, it's his little theorem, it applies, and hence I can say that 2 to the power of p minus 1 is congruent to 1 mod p. Okay, so that's all very well, but of course the question is asking me about 2 to the power of p squared. So we need to try and think how we get from p squared and somehow get that in there. So it's very much like the previous questions where we try to think, okay, how do I get 2 to the power of 50 in terms of what's useful here? How do we get 2 to the power of p squared in terms of what's useful, which is 2 to the power of p minus 1? So p squared, well, that's only 1 away from p squared minus 1. Okay, so what I've written there isn't accurate, but I can fix that by multiplying by 2. That, of course, 2 to the power of 1. So now that is equal to that. And hopefully you can see why that is useful, because p squared minus 1, I can factorise into p minus 1, p plus 1. I've still got this 2 here. And then using the power rule, a to the power of m all to the power of n is equal to a to the power of mn. Of course, going that way, I can just write that as 2 to the power of p minus 1 all to the power of p plus 1 times by 2. And that is what I need. Because I know that that is congruent to 1 mod p, that is going to be 1 to the power of p plus 1, which is just 1, and then times by 2. So we can see what the answer is, but we just need to kind of write it down properly. So I can say that hence 2 to the power of p squared mod p is equal to 2 to the power of p minus 1 all raised to the power of p plus 1 multiplied by 2. And that in turn is congruent to 1 to the power of p plus 1 times by 2 mod p, which is 2 to the power of mod p. Okay, so it's just a matter of, not panicking at the start. It would probably be, I don't know, 4 marks or so, so it wouldn't be classed as particularly tricky, just a bit odd, just a bit awkward, and certainly quite unsettling. Write down what Fermat's last theorem tells you, and then think, how do I get from what I've got to what I can use? This question is then a kind of more extreme example of that. So, show that 3 to the power of p minus 3 to the power of p minus 2 is congruent to negative 1 mod p. So in that previous one, we had a much simpler expression. We were just asked to find it, essentially simplify it. Here, it is at least to show that, so we can see what we're aiming for. It says for prime p is greater than 3. You can see, of course, if p equals 3, then we get something that's absolutely kind of not congruent at all. And then presumably we should be able to use that result to help us work out this. So this, of course, is, a huge number. There's no way that that's going to fit into your calculator. So that 24 to the power of 19 minus 3 to the power of 80. First you might be thinking, well, isn't that just an even number? No, of course. I mean, that will be even, but of course, any even power of 3 itself is going to be odd. So it's going to be an odd number. Don't know what it is. We need to find 2 prime factors. So let's use a similar tactic to the one we did before. We know that P is prime. And I can also say that the highest common factor of P minus 3 and P is equal to 1. So I can use Fermat's little theorem. Okay, again, you would get a mark for stating that. So please, please, please don't forget to write it. Or not forget, I think some of you are just, oh, it's not important. Please make sure you put that. So Fermat's last theorem tells us that A, what is the A? Well, I guess the A here, it's going to be that, isn't it? It's the P minus 3. It's what I've written in the bracket there. So A, which is P minus 3, to the power of the prime minus 1, is congruent to 1 mod P. Okay. So, given that, we try and work up to that. I think what I did last time, yeah, I started with the 2 to the P squared and then got a P minus 1 in there. I think what I'm going to do this time, I'm going to think about it the opposite way around, because I can instantly see what I can do to this to get me one step into there. I need to change this. I need to get a power of P minus 2. And I can instantly see how to do that. I would just take a P minus 3 there. So I'm going to take out one of those P minus 3, write it as a separate bracket, separate factor, and then that will change down to a P minus 1. So that statement there, and that would imply that P minus 3, I'll just put that one there, and P minus 3 to the P minus 2. So together now, get us back to that. That is going to be congruent to 1 mod P. And if we look at what we need, okay, I need a 3 next to that. We can, of course, expand that bracket, can't we? I have got P multiplied by P minus 3 to the power of P minus 2. And then I've got negative 3 lots of P minus 3 to the P minus 2. So I haven't, done anything. I haven't changed anything. All I've done, taken a bracket out there, and I've expanded that bracket. So I haven't actually altered what any side is. This, because we're dealing with mod P, that is divisible by P. Because it is divisible by P, it is congruent to 0 mod P. So that just takes us to 0 minus 3 lots of P minus 3 to the power of P minus 2 is congruent to 1 mod P. And then, well, I'm not going to divide by negative 1. I'm going to multiply by negative 1 just because division's always a little bit kind of dodgy. But I have what we need. Okay, so again, I think that looks very scary at the start. What on earth is going on? But just think, right, write down Fermat's little theorem and then what you need to do to get there. Okay, now the second part. Find two prime factors of n. So our expression here is n to the power of 24. Sorry, n equals 24 to the power of 90 minus 3 to the power of 80. And presumably we are going to be using the result that we've just proved. Which is that 3 times by P minus 3 to the power of P minus 2 is congruent to negative 1 mod P. If we're thinking about prime factors, you should just be able to see one by inspection. find two prime factors of n. There I've got a 3. 24 is divisible by 3. I can just see by inspection that 3 is a prime factor. And of course, at the very start of the question, the expression that we needed to prove only worked for p being greater than 3. Of course, 3 is still a prime factor. We haven't used that result to work that out. Presumably that result is going to help us to work out the second one, but that, just is simply the first one. So I can just put that to one side, don't need to worry about that bit again. But now the next part, we obviously need to use that. Can't see immediately what's happening, so let's see what we can do with this expression here. So I've got 24 to the power of 90 minus 3 to the power of 80. There's a 3 there, and I've certainly got a 3 here, but I think it might be useful to get 3's in there also, and of course I can, because 24 is 3 times by 8. So I can write that as 3 times 8 to the power of 90 minus 3 to the power of 80. And I've got a common factor, haven't I? I've got a common factor of 3 to the power of 80. If I take out 3 to the power of 80 from there, I'd be left with 3 to the power of 10 and 8 to the power of 90. And I've got a 1 there. What can I do now? Well, I've got actually difference of 2 squares, haven't I there? I can write that as 3 to the power of 80, 3 to the power of 5 times by 8 to the power of 45, minus 1, and then 3 to the power of 5 times by 8 to the 45 plus 1. Actually there, it spells it out, doesn't it? That 3 being the prime factor. So if you haven't got it by inspection, hopefully at that stage, you can just see what's going on. Now there's something quite interesting happening here. So what I've got here is something to the power of 1, something to the power of 9, all to the power of 5. So again, I'm just simplifying it as far as I can. I've got 3 times by 8 to the 9, all to the power of 5 minus 1. And then I've got 3 times by 8 to the 9, all to the power of 5 plus 1. And I think I've kind of done what I can, haven't I? I've factorised this, I can't factorise this anymore, but I've simplified those powers. And look at this result at the very top. I have got a 3, and then I've got an 8 to the power of 9. So if that 8 is equal to p minus 3, it would make p equal to 11. Okay, 11's prime. And then 11 minus 2. Okay, that works with the 9 as well. So using the above result, which we can, because 11 is prime and HCF 3 and 11 is equal to 1. So I can use this result, and we know that, in fact, we didn't, that's already being considered, hasn't it, in our proof, so I wouldn't necessarily need to kind of write that down. So I know that 3 to the power of p plus 1, which is 8 to the power of 9, that is congruent to negative 1 mod 11. Okay, so this is congruent to negative 1. This is congruent to negative 1. So let's just kind of spell out that that's also going to be the case when we've got that power of 5. So that also takes us, of course, negative 1 to the power of 5 is negative 1. So now if I put it back into here, so hence n is equal to 24 to the 90 minus 3 to the 80. I'm not going to go all the way, I'm just going to go to this end line here. 3 to the 80, 3 times by 8 to the 9, all to the power of 5 minus 1. And 3 times by 8 to the 9, all to the power of 5 plus 1. And that mod 11 is equal to 3 to the power of 80. That is congruent to negative 1 minus 1. This is congruent to minus 1 plus 1. Don't know what that is, doesn't matter. That's equal to negative 2, but look here, I've got a 0. And because it's congruent to 0 mod 11, hence I know that n is divisible by 11. So hence 11 is prime, 11 and 3 are my prime factors. Okay, so this is quite extreme, and there was a question very, very similar to this in one of the recent exam papers. It was the end of the paper. Everybody hated it. Not very many people getting, even more than half marks on that question. Okay, now, questions for you to try. There aren't any like this last one. Only 3. And then the homework's going to be coming shortly. But it's essentially one with all the 9s, the easier algebraic one, and then pseudo prime. And